Hello, and welcome to the second video of our Frontly with Google Apps Script series. Google Apps Script is a versatile tool that lets you create webhooks for use with Frontly, enabling your apps to interact with others immediately as things happen. Start by learning how to use the key functions for reading and updating data in your Google Sheets. These are crucial for managing your data effectively, like when you need to add new customer details to a spreadsheet automatically. You'll also work with a simple placeholder function called generateContent. For now, it doesn't do much, but it's there to help you plan for when you start working with actual data. The heart of your webhook is the doPost function. When data is sent to your webhook, this function kicks in, processing the data by reading, updating, or creating new content. It's an essential part of your script that makes sure the data you receive is put to use. The DEBUG tab in your spreadsheet is where every action from your doPost function is logged. This is like keeping a detailed journal of events, which is much better than using random notes for tracking. This method is more organized than traditional debugging, which tends to involve looking through various logs. With everything recorded in one place, it's easy to see what's happened over time and sort out any issues. When it comes to testing your webhook, Postman is invaluable. It's a tool that lets you send test requests to your webhook to check how it handles them. This gives you a clear idea of how your webhook will perform without having to test directly in Frontly. Postman is like a testing ground. It's where you can safely experiment with different requests to make sure your webhook responds correctly. You can change settings easily and make sure everything is working as it should. Once you're happy with how your webhook works in Postman, you can confidently move it to Frontly. Thanks to all your testing, you know your webhook is ready to handle real data. Let's start at the ground level with the fundamental building blocks of our script. We'll explore the basic functions that are essential for reading from and updating rows in our spreadsheet. These are the tools that will allow us to handle data effectively and are the foundation upon which we'll build more complex operations. The readJSON row from sheet function is designed to grab data from a specific row in a Google Sheet and turn it into a JSON object. This is really handy because it makes the data easy to work with in your script. It's straightforward. You tell it where to look, and it fetches the data for you. Now, when you're writing code, you often want to check if everything is working correctly. That's where readJSON row comes in. This function is a debugger. It uses readJSON row from sheet to grab the data from a row and then it shows you what it got. It's a quick way to make sure that the data you're expecting to see is actually there. For adding or updating data in your sheet, you use writeJSON row to sheet. This function takes the data you formatted as a JSON object and puts it into the specified row in your sheet. It's like filling in a form electronically. You put each piece of information into the right field. And just like you would proofread a form before submitting it, you use writeJSON row to test out writing data to your sheet. It's a debugging tool that helps you make sure that when you try to save new data to your sheet, it goes into the correct place without any issues. Both readJSON row and writeJSON row are there to help you test things out. They're about making sure that your code is doing what you expect before you start using it for real tasks. They help catch mistakes early, saving you time and trouble later on. With our ability to manipulate spreadsheet data established, we now turn to the scaffold of our application logic. Here we'll introduce a dummy generateContent function. This part acts as a stand-in for future, more complex operations, allowing us to design our workflow and anticipate how we'll handle incoming data to generate meaningful responses. The generateResponses for all rows function is like an assembly line worker who goes down a list, your Google Sheet, and fills in a specific detail for every item that needs it. Here's how it works. This function looks at each row in your sheet that isn't empty, and for every row it finds something called a prompt. Then it gets creative and makes a response based on that prompt. After it comes up with this response, It doesn't just keep it to itself. It puts it right back into the sheet in the response column. It's a bit like someone going through a questionnaire and filling out the answers one by one. There's also a helper function named generateAllRows. This one is straightforward. It's just there to make it easier to start the whole process. Instead of telling generateResponses for all rows where to go and what to do every time, you just call generateAllRows, and it knows to go ahead and kick off the operation using the predefined sheet details. Lastly, we have the generateResponse function. This one is like a specialist on that assembly line. It focuses on just one row at a time. It takes a look at the prompt in that row, does its magic to create a response, and then carefully writes that response back into the row. If it goes to a row and finds there's no prompt, it doesn't create a fuss. It simply moves on, letting you know it didn't find what it was expecting. In essence, these functions work together to ensure that every row in your sheet that needs a response gets one, and they make sure you're informed every step of the way, whether everything's going smoothly or if there's a hiccup somewhere. Please note that the generateResponse function is quite versatile. It can be as simple or as intricate as you need it to be. In the current form we've shown, it's using a very straightforward approach where it simply takes the existing prompt from a row and adds _frontly to the end of it to create a response. This is a basic example, sort of like someone automatically adding "and friends" after every person's name to make it sound more inclusive. However, this is just the starting point. Instead of just appending text, you could program it to do much more elaborate tasks. For example, it could call various APIs to fetch data or perform calculations based on the prompt. It could even interact with OpenAI's powerful APIs to generate highly sophisticated and contextually relevant responses. By leveraging these more complex capabilities, generateResponse could become an intelligent agent, processing natural language prompts and crafting replies that are not only relevant, but also nuanced and detailed. So, while our current code is a basic dummy implementation, the sky's the limit when it comes to enhancing this function's complexity and its potential applications. Now that we've set the stage with our functions, let's see how we can keep track of their performance. We'll explore how every execution of a doPost webhook can logged in the DEBUG tab, providing us with a clear audit trail. In the world of webhooks and Google Apps Script, your clues are the pieces of data that pass through your script, and you need a way to keep them all in order. This is where Debug Index comes into play. It's like a bookmark in your detective notebook, telling you what page you're on in your investigation. The Read Debug Index function is your way of quickly flipping to your bookmark to see where you left off. It reaches into a special cell in the debug sheet of your spreadsheet, grabs the number that's there, and tells you, "This is clue number 42. That's your debug index. If it can't find a number to tell you, it raises a flag, letting you know something's amiss by saying, "Hey, there's no bookmark here." Now, when you have a new clue to log, you don't want to overwrite the old one. The Write Debug Index function lets you update your bookmark. You tell it, "We're now on clue number 43, and it carefully writes that number down in the same special cell. It's like sliding your bookmark to the next page because you've just added another piece of information to your case. And then there's Write Debug, a straightforward function you use when you want to test if your bookmarking system is working correctly. It's like doing a dry run saying, "Let's pretend we're on clue number 10, and making sure that the bookmark gets moved to page 10. It's a simple checkup to ensure that when you're in the thick of your web detective work, your bookmarking system won't let you down. Now that we've seen how our functions can manipulate data and how we've prepared our dummy content, let's focus on how we monitor and refine these processes. This is where the doPost function comes into the spotlight. The doPost function acts like a vigilant record keeper for your web app. When it receives a post request from Frontly or another API debugging tool like Postman, it takes a systematic approach to handle this information. Instead of just processing the data, it meticulously logs every detail in a special DEBUG tab in your spreadsheet. This tab becomes a detailed ledger of all the interactions your script has with incoming data. By logging the information in the DEBUG tab, you create a centralized and easily accessible record of every execution. It's much like having a dedicated journal where you note down important events, rather than sticking post-it notes all over your desk. This method trumps traditional debugging, which might have you sifting through various console logs or execution records. With everything neatly recorded in one place, you can quickly scan through the history, identify patterns, troubleshoot issues, and understand the behavior of your webhooks over time. This approach to debugging your webhooks by using a spreadsheet tab is efficient because it organizes your data in a familiar format. It's not just about keeping track, it's about making the tracking meaningful and user-friendly. Whether you're looking to confirm that a particular execution took place, or you're trying to pinpoint where something went awry, the DEBUG tab provides a clear and chronological trail of digital breadcrumbs. The doPost function is a vital part of our script that deals with incoming post requests. When data arrives, this function is the first to meet it. It starts by logging its activity, which is a great way to keep track of what's happening. Think of it as making a little mark on a checklist every time a new package arrives. Then, doPost takes the data, which is sent over as a JSON string, and carefully opens it up to see what's inside. It's kind of like opening a letter. Inside that data, there's a special counter called debug index that keeps track of how many requests have been handled. It's like a stamp on the letter that says which number in the line it is. After reading the counter, the function takes the data from the request and places it into a specific spot in our sheet, starting at row 10. It's methodical and orderly, ensuring that everything is logged correctly. Then it updates our counter so we're ready for the next piece of data. Now it's time for the real work. The function calls on generateAllRows to update our sheet's data. It's as if the function rolls up its sleeves and gets down to business, making sure every row is taken care of. Once the job is done, doPost sends a response back to the sender. It's like saying, "We've finished everything you sent us," and ensures the sender knows the request has been completed successfully. But what happens if things don't go as planned? doPost doesn't just shrug and move on. It makes a note of the error and sends a message back explaining the hiccup. This isn't just about being polite, it's also about making sure we can fix any problems for the next time. With our doPost in place and its debugging ready, it's time to test. We'll use Postman, an API debugger, to simulate calls to our doPost function, ensuring that we can observe and refine the process in a controlled environment. When you're working with webhooks in Frontly and our Google Apps script, GAS, testing and making sure they're receiving and processing data correctly is crucial. This is where a tool like Postman comes in very handy. Here's a step-by-step on how you would use Postman to debug your webhook calls. Step 1. Extract the webhook URL. After you've written your Google Apps script and deployed it as a web app, it will give you a unique URL. This is your webhook endpoint. Think of it as the address where all your data deliveries are supposed to go. Step 2. Set up Postman. Open Postman, which is like your digital post office for sending test packages, data, to your webhook address to see how it responds. Step 3. Configure the post request. First, in Postman, create a new request and set the type to post because you want to send data to your webhook. Second, paste the webhook URL you got from GAS into Postman's address bar. Step 4. Set the content type. Webhooks expect the data in a certain way. To tell your webhook that you're sending JSON, you need to set the content type header to application JSON. It's like telling the post office you're sending a fragile package so they handle it with care. Step 5. Craft the raw body. First, In Postman, go to the Body tab, select Raw, and then choose JSON from the drop-down menu that appears. This is where you'll put the data you're sending in JSON format. Second, type in your JSON data. This should be a set of key value pairs that your webhook is expecting. Step 6. Send your request. Hit the Send button in Postman. This is like dropping your package in the mailbox. Step 7. Check the response. After you send your data, look at the response. If everything's working, your webhook will process the data and send back a success message. If something's wrong, you'll get an error that you can use to troubleshoot. Using Postman to test your webhooks gives you a clear and controlled environment to make sure that when your GAS script is live and waiting for real data, it will behave exactly as you expect. It's a powerful way to debug and ensure your webhooks are set up correctly before they go into action. Finally, after ensuring everything is polished with Postman, we'll transition to the real deal, using doPost from within Frontly. This step will show us how our webhook operates in the environment it's ultimately designed for. Once you're satisfied that your webhook is working perfectly in Postman, making the switch to using it with Frontly is straightforward. All the hard work you've done in Postman will pay off because you'll be moving over a tried and tested webhook. It's like rehearsing a play in an empty theater before the audience comes in. You've had the chance to work out all the stage jitters, and now you're ready for the live performance. With Postman, you can iron out all the creases first, ensuring that when you do integrate your webhook with Frontly, it's a seamless transition, ready for the real world. Apps, Script, and Frontly together offer a robust platform for creating webhooks that allow for real-time data interactions. The journey begins with mastering the essential functions for manipulating data, akin to laying the groundwork for efficient data management. The generateContent function, although a placeholder, sets the stage for handling actual data influx in the future. At the core of the system is the doPost function, which is triggered by incoming data and performs necessary operations like reading, updating, or generating content. This function ensures that incoming data is not just received but also utilized effectively. Logging each action in the DEBUG tab offers a streamlined approach to tracking and debugging, providing a single organized record of the webhook's activities. This method simplifies the debugging process, allowing for an easier review and resolution of any issues that arise. For testing purposes, Postman emerges as a crucial tool. It allows for thorough and precise testing of the webhook in a controlled environment, offering clear feedback and a user-friendly interface for adjusting and refining the webhook's behavior. In conclusion, once your webhook has been meticulously tested with Postman and you're assured of its functionality, you're well-equipped to transition to using it within the Frontly environment. This process represents a full cycle of development, from conceptualization to real-world application, ensuring that your webhook is not only well-crafted, but also primed for the dynamic interactions it was designed to handle. With the confidence gained from rigorous testing and debugging, you can look forward to seamless integration and operation of your webhooks in the live environment. Ready to harness the power of webhooks and take your web applications to the next level? Don't miss out on the latest tips, tricks, and updates. Subscribe now and become part of a community that's shaping the future of real-time data interaction with Google Apps Script and Frontly. Whether you're a seasoned developer or just starting, our resources will guide you through every step of the process, from writing your first line of code to deploying fully functional webhooks. Click that subscribe button and join us on this exciting journey to unlock the full potential of your web applications. Let's innovate together. Subscribe today.